Hello. Hello to everyone from Finland and welcome to the second part of our Don't Fear the Fire webinar series. The topic of the first part was railway, but today the focus is on construction. I hope everyone will find this webinar valuable and you will have an interesting 1 hour ahead of you. Ask any questions at any point of the presentation using the live Q&A chat. All questions are private by default and not visible to the rest of the audience. Mark your questions confidential, and we will answer you later after this webinar if you want. General and popular questions will be shared and answered in the end of the presentation. After this webinar, we certainly hope that you will know how to complete your composite, what it does mean that how to improve fire performance without actually changing your composite. Also, you will know what are the relevant fire standards in the construction sector. Moreover, how we can help you to achieve your goals. My name is Ari Hokkanen. My role as CTO is to make sure that we have a superior technology to offer. My background is in composites since the first summer job forever ago. And I'm here with my colleague Trevor.
Good morning, everybody. I'm Trevor Fielding. I'm the Technical Business Manager here at Finesta Coatings.
Finesta Coatings is investor-backed SME conveniently located in Lahti, Finland, only 1 hour from Helsinki Airport. And we are ISO 9001 and 14001 certified since 2017. What do? We design, manufacture, and supply coating. But to be more specific, those coatings are fire protection coatings targeted for composites. We have two unique in-house technologies: ceramification, where polymeric material converts to ceramic material when exposed to the fire, and controlled intumescence, where polymeric material starts to foam and expand when exposed to fire. Our other expertise is in fire retardant treatments that are designed to natural fibers. So, what we see as a fire challenge in the composite market. First of all, composites are chosen as a last resort when other materials fail for these particular reasons. They are lightweight, they have a high strength, especially the strength-to-weight ratio is superior. They have a nice consistency when processed in different techniques. They have a nice appearance, different colors, different gloss levels, textures. They can be used outdoors. They're UV resistant. They never corrode, and they can be processed in inexpensive ways to different shapes with different techniques. But the truth is that because they are oil-based, made from oil, they do burn. And we are seeing this as a missing link of the composites world. Of course, you can make composites fire protective. You can use add-in fire protection, meaning that traditional solutions are specialty resins, for example, phenolic resins, PFAs, and other resins, or you can transform your traditional resin epoxy polyester to fire retardant by using fire retardant fillers or fire retardant additive. Also, you can use intumescent gel coats to protect your laminate. But this will lead to compromises. So actually, you are losing the great benefits from the composites because of you are adding the fire protection element. So they are not anymore lightweight, and you are going to lose the strength, and they are not easy to process due to high viscosities, and usually you cannot use them outdoors. So adding fire protection will lead to compromises. Our solution, on the other hand, is to use fire protection coating. And they go under the trade name of Finesta Red. Finished red includes two product families, hybrid red and pure red. Hybrid red is the ceramifying product, the one that transfers to ceramic material when exposed to fire, and pure red is the expanding intumescent product that exposed to fire will start to expand. These are applicable with common tools, just normal spray units, spray equipment, and you can have different colors, you can have different gloss levels and different finishes. So they act as a normal paint. Even we don't like to use the word paint, we use the word coating. In practice, it means that red completes your composite, meaning that it will just add that missing fire element to your pie chart. So there's no need to change your composite, you just add that fire protective coating to complete your composite. But how red actually works? What's the story behind it and the technology? So let's open up that a bit. There's a short 20-second video that we can show, and let's watch that first without any commentary, and then some commentary. Okay, let's rewind the tape. So what we have here, we have a standard high-performance composite. This is epoxy glass fiber composite, standard epoxy at room temperature, and this is coated with two-layer system. This is coated with pure red underneath, primer coat, and a hybrid red on top. Blue-colored hybrid red, and there are some water droplets to see the nice effect. What happens next is the Bunsen burner is introduced on the right side to the surface, and the surface temperature starts to increase rapidly. And here, about after 300 degrees, happens the next stage, which is the organic material starts to burn away. So when the increase in temperature goes above 200, 250, the organics are going to burn, and that's completely okay. There's a small flame, but that will start, which starts, but then it will extinguish. And after it's extinguished, after 500, 600 degrees, there's no more organic left, and the hybrid red will start to ceramify. What happens at the same time is that heat will transfer to the other side of the ceramification layer, and that will transfer to the pure red layer, will start to expand. And when it starts to expand, it will push that kind of ceramic bubble in the surface. And the ceramic bubble will protect the intumescent layer beneath. So without the ceramic bubble, the intumescent layer will just, oops, sorry about that, will start to expand without control, and that's why we call it controlled intumescence, and then protected by the ceramic bubble. Let's watch it again. And that's where happens the organic material burning away, ceramification happens, and now it's stable. So after 1000 degrees, there's no more organics left, of course, and there's only ceramic material on the top, ceramic bubble protecting your composite. And this is stable. You can burn it for, we haven't burned it for 5 weeks, but maybe you can burn it for 5 weeks, but you can burn it for hours, and the heat will not transfer more to the composite, and the flame will not spread. And it even goes red hot. Even you give it more flame, it just goes red hot and really doesn't care anymore. It's like burning tiles. So in a nutshell, maybe it's better to watch in a screenshot. So the first, you have just a standard composite in standard conditions. Then the flame Bunsen burner is introduced and starts to increase the temperature very rapidly, and organic material burns away, and that's okay. And then only inorganic material is left after several hundred degrees, and then that is stable and gives stable protection more than 1,000 degrees. Fire testing. What is fire testing? How we quantify fire? So everything comes down to the heat release. So how much heat is produced during the fire? But of course, heat release is just one element of that. There is ignitability, so there's time to ignition. Everything will ignite eventually. And then there's a flame spread after the ignition, how much the flame will spread when the ignition has happened. And this we call reaction to fire. Then there is a second stage of the burning, which is the resistance to fire, meaning that how much burning droplets are produced and how much, if there is a structural failure, how much heat is transferred to the structure itself. And then there is combustion products, meaning that the smoke capacity and smoke toxicity is also a severe factor in the big picture. We have our own fire lab here in-house, where we can support projects, we can support R&D, we can make several burns a day. We can offer that expertise. We have that combination of composites, know-how in composites, know-how in coatings, and know-how in fire. So we don't just burn and keep curves, we also analyze, and we also can make improvements. Every composite is a unique, so there's no one solution fits all, one size fits all. That's not the case here in composites. Maybe in metals, maybe in wood. Metal is metal, wood is wood, but composite is not the composite. Every composite is unique, and every composite needs a little bit tailored solution. And this is the unique offering that we are offering for the composite sector. Capabilities in-house, current capability. So we have a cone calorimetry. That's a basic test, a standard test for many market sectors. We are UL94, thermability of plastics we can do. Ignitability test. We have thermal insulation and flame spread tests. We can do those in indicative way. Today, we don't yet have smoke and toxicity analysis in-house, but we can use third party. We have very good third party partner for that. So we can measure all the elements during the burn. Okay, so now I will hand over to Trevor.
Thank you, Ari. So the first question many will be asking is why use coatings? What are the benefits to using coatings for fire protection of composites? There are a number of good reasons, not least of which are a few photos here showing why we want to use coatings and why I believe coatings is the answer for many applications. Obviously, you have the full choice, a full range of colors and gloss and surface effects that you can create when you apply a coating onto a composite. They're very easy to apply. We would recommend spray application for our coatings, but they can also be applied by a roller or a brush application. The other beauty about coatings is you can build them up in layers. So the bottom photo in the middle there, you can see that you can put several layers of coatings on, so you can adjust to the conditions. You can use a single coat, or you may want to put a multiple coat system down. For example, as you can see, to get a really high gloss finish, then you may want a clear top coat to get a really nice finish for the exterior of train vehicles, for example. And the dirty looking photo on the bottom left is also a good reason for using coatings. We can fix poor composites, whether it's poor gel coats or poor surfaces. A coating can cover the difficulties of the composite itself and mend the failures or the pinholes or the poor appearance that you get when you're manufacturing your composite. More specifically, where are the benefits to our red technology? So as I mentioned earlier, just repairing a composite surface is one. The flexibility, being able to produce one part or 10 parts or hundreds of parts, not being totally committed to having to use a coating for every single part. Coatings, of course, can be used as a coating that will last for a certain period of time and then can be maintenance. You could repair a coating. You could take off areas that have been coated, that have been damaged, maybe physical damage or maybe from other aspects, and then replace that area and extend the life of surfaces. And then with our red technology, you're getting all the properties in one. So we're not saying we just give the fire protection, but the technology also gives you the outdoor weathering. It gives you excellent UV light resistance. This is predominantly inorganic chemistry, inorganic technology. So it gives very good UV light resistance. If you're looking at public areas, then you're always concerned about anti-graffiti and scratch and wear and tear resistance. And again, our red technology gives a very hard, tough, resistant surface that can be easily cleaned. And of course, the main purpose of today's presentation and why we're promoting this technology into this market is that it gives us very confident and consistent fire protection. I'll show you a slide a little later on showing how consistent we can get this heat release data. So in effect, we're saying by using red, you can certainly pass some of the tougher test standards, not just in the fire world, but also in terms of accelerated weathering and outdoor resistance testing. Reaching the new levels of fire protection and thermal insulation, so taking our technology will take you to that extra level, maybe an improved level in terms of meeting a standard if there's a classification system, and certainly in terms of blocking the temperature and thermal properties of the coatings. And for example, potentially replacing phenolic resins. As we say, we're using standard composites. We don't need to use specialty resins. Perhaps removing or reducing the level of certain fillers, such as ATH, which always weaken a composite structure. And also potentially avoiding the use of veils to provide the fire barrier. A little bit more about the application of our coatings. As I mentioned earlier, we prefer spray application. It gives you the most consistent and the best appearance. But these coatings are also variants of these coatings are available to be applied by brush or by roller application. Very important part of this process, certainly if you're producing large panels in the construction industry, is that the coatings cure at room temperature. There's no need for large ovens or extra energy to be put into the coatings. They will cure at room temperature. A heat boost can help, but certainly it is possible to cure them at room temperature. Also is how to apply those within existing composite processes. The base coat is also potentially applied as a gel coat in mold processing, but also we can apply some of these coatings into, for example, filament winding processes. So there's some versatility into the application of the coatings and bringing that into part of the existing composite production processes. And as I mentioned earlier, the importance of being able to coat individual items, very flexible. You don't have to coat 100 bridges. You can coat one bridge with our coating, or 100 different components for cladding or anything else. And what we've found so far, anyway, is that the technology seems to work with all types of composites. It works in different ways. It works to different extents, but the compatibility with epoxy, with phenolic, with polyester, glass, carbon fiber, basalt fiber, pretty much everything, even polyfluoroalkyl alcohol, PFAs. We've been looking at all types of composites, and we've not found a situation where the coating technology doesn't appear to work. Thermoplastics, interesting area of development as well, of course. People looking to try and move into recyclable materials, and thermoplastics is one direction that is being explored. I'm pleased to say that we've had some good results with our red technology in combination with materials such as the Arkema Elium material, Polyamide 6, PA12 as well. We don't have any real issues with the compatibilities. We do have one or two thermoplastics, unsurprisingly, that do cause some problems, such as polypropylene and PVC. But there again, maybe with some primer technology or some treatment technology, we would be able to make our technology work alongside those substrates as well. So more specifically, moving into the second part of our presentation, which is more focused specifically on the construction market. And these next set of slides are a little bit technically heavy, so hopefully I won't lose you, but it's important to explain what the key standard in the construction market is with regard to fire performance and fire assessment. This standard is the EN 13501-1 standard. I'll try not to make it too technical. Please, you'll get a copy of the presentation after this webinar, so please take a look at what we have here. But yes, here's a little bit of detail on 13501, which is really the core test standard used for fire assessment of construction products. So this standard is the EU classification relating to reaction to fire. So very much looking to how, when you start to burn something, how it reacts. How does the flame spread? How does the flame grow? Does it start in the first place? Very much looking at those sort of elements in our fire diagram. It's often replacing existing national standards, but also complements sometimes the national standards. So sometimes we have requirements that require both an EN 13501 test protocol, but also maybe a national standard such as a DIN 4102. It's a simple and easy to understand standard, and it includes a very important test, something called the SBI test, the single burning item test. We'll speak a little bit more about this test later in the presentation. Some elements of construction and buildings do have their own standards as well, or additional standards to 13501, such as external roofs, flooring, cabling and piping. So how does it work? So the 13501 is based on two parts. The classification process is based on two parts. The first part is pretty easy to understand. It's an alphabetical classification. A is the best and E is the worst. And really you're looking at A1, A2 for non-combustible materials. And as you're aware, standard composites will burn, as we said earlier. They are organic in basis, so it's very unlikely you'll be able to reach an A1 or A2 classification, whatever you try and do with a coating. But a B classification is a very good result. It means it's a very limited contributor to fire. It means that when you have a fire, that you're not fueling that fire or promoting that fire to any great extent. So really, in terms of what we can do in terms of composites and protecting composites, the target is to try and get this B classification. The standard composites won't get to a non-combustible situation. So a little bit to do with the tests. The detail is in the table, as you can see. So the classification is related to three different test standards or test methods that are used. As I mentioned earlier, this SBI, the single burning item test, is the core for this classification. And you have different parameters, different data points that you need to meet to determine the classification and get below, basically, the different parameters. And these are the parameters. So the figure refers to what they call the fire growth rate index. So it shows how quickly the fire takes hold and how far that growth, how far that heat is released, how quickly that heat is released at a certain point in time during the fire. The total heat release, obviously a very important number, how much is actually going to burn over the test period, which is 600 seconds. And then the ignition as well is important, how quickly the material will burn in the first place. And this is this B classification I was talking about, just highlighted here. So those are the key numbers that we look for when we look for B classification, less than or equal to 120 watts per second for the FIGRA, and less than or equal to 7.5 megajoules for the total heat release. I mentioned it's two parts to the EN 13501. So the second part of this classification is to do with smoke emissions and flaming droplets. I won't go into the details. They just see on the screen there that there's a sort of three choices, three levels of classification for each of those aspects to the material. And so if you want to get the best result, you're really looking for a BS1 D0 is your target result, if you like, for composites. I'm pleased to say that we get a pass with our red technology. We get a BS1 D0 classification under EN 13501-1, which is a very important classification and certification for our products. A few further details on how we've achieved this. I won't run through the full testing, but the SBI test, this is the core test we mentioned earlier, was run over polyester glass fiber. And this is a typical set of numbers that we've managed to achieve with our red technology. And again, highlighting that we have an excellent result on total heat release. So being less than 7.5 megajoules is the classification requirement. And actually, we were well below 2, we're below 1.5 megajoules on this particular test. So really a very clear pass and a very clear B pass under this test protocol. And as I mentioned earlier, it also needs to pass the ignitability test requirement. And the photo on the right is actually the real life photo of the coated panels being tested under this SBI test. So this is actually the correct photo with this table of results. So moving more generally into where red can be used and moving away from just EN 13501. So there's a number of areas in the construction industry that certainly we have found the red technology to be useful. Not just in standard building products where the EN 13501 is applicable, but also for bridges and utility poles, for general architectural features, for outsides of buildings. Also in the rail and road infrastructure, very clearly the red technology can boost fire performance in that aspect, in those sectors. And in terms of resistance to fire, potentially in the tunnels and on the offshore applications where you need to meet certain thermal insulation properties. As I mentioned earlier, we've found good results with thermosets. We're finding good results with thermoplastics, that's including 3D printed parts, and even exploring into the natural fibers and to bio-based materials. So quite a broad range of areas where our red technology is finding utility. We recognise that fire is not the only requirement in the market. The market is also looking for a number of other aspects relating to the appearance of the product. Obviously, how composites can be put against powder-coated metal, for example, for applications. Durability is a very important aspect. Some companies are looking to have some translucency, some transparency, so you can see what is underneath the coating. And also sustainability. So recognizing these aspects as well, and those are, if not being addressed already, those are projects that we're working on within our laboratory at the moment. For the rail and road infrastructure, it's a little bit different to the main construction products area because there aren't any fixed requirements. There's not a clear standard. It is very much down to national network and agency requirements. So you have to be a little bit more aware of what is needed and really set those targets up right at the beginning of the project. Obviously, you can call on EN 13501 as one possible standard to reach for. If you're in the rail industry, then there's the rail vehicle standard, the 45545-2. That's also one that can be used. Pleased to say that the red technology can meet hazard level 2 performance in 45545. And then also, again, national standards. And the most important thing is to guide and to determine what the standard is for the application and location in question. A few case studies coming up now. So first of all, we had a very successful project. This is a couple of years ago now, in 2019. Composite footbridges over the UK rail network. A tubular steel bridge was basically falling apart and was abandoned and needed to be replaced. Lancashire County Council were unprepared or unable to put any new foundation work in place, so they needed a lightweight answer for this application. Obviously, it's outdoors, needing the weather resistance, needs at least a 25-year durability lifetime, and it needed the fire performance. And we were pleased that our red technology passed all these standards with flying colours. It was an infused vinyl ester single 27-metre piece that was actually produced as this bridge, and then our red technology was painted on top. Wasn't the color we would have perhaps chosen. They specified a cucumber green color, but that's the color that's up in the northwest of the UK. Actually, it's 2 footbridges up in the northwest of the UK with this color and this specification. But as I say, in this situation, the red technology was passing the standards. The BS476 particularly is the local standard and related to spread of flame, and we get the best result with red for that standard testing. A second case study that, again, demonstrating the durability and outdoor weather resistance of our technology. So this is utility poles, so electricity transmission lines in Northern Europe and also in the States. Often these traditional lines have been obviously supported by timber structures. Timber is not the most durable when it comes to low-level brush fires, and also the woodpeckers can also cause mayhem. So these are being replaced by composite utility poles, and what you see in the picture there is what we call our chocolate pudding brown coating applied to a composite utility pole being installed to replace a wooden pole. And again, these are the sort of challenges that our red technology meets very satisfactorily. So low-level bushfire resistance, some surface fire protection, so surface spread of flame, the UV light protection, of course, outdoors, longevity, certainly more than 50 years. A lot of these poles are guaranteed for greater than 50 years, so we have to meet a very long-term UV light protection requirement. The woodpecker resistance may sound funny, but is actually a genuine problem that is seen throughout the electricity transmission line networks. And again, this is a point where we were able to incorporate the coating application into the manufacturing process, in this case, a filament winding process. And then 1 or 2 further slides on different construction applications. Mentioned tunnels and offshore. This is more to do with the resistance to fire, so the structural properties, retaining those structural properties during and after a fire event, so that the whole structure doesn't collapse during the fire. So we're pleased to say that red is acting as a very good thermal barrier, and you can get those structural properties through the use of our red technology, and extending the lifetime and protecting, obviously, those structures, allowing people to escape the fire, or allowing the structures to be maintained post the fire event so they can be dismantled safely. And plenty of different testing formats related to here. I'll show you a curve or 2 in a few minutes on how we test thermal insulation. So a little bit on performance data. Yeah, so here's the curve actually on the thermal insulation. So very interesting, couple of curves here actually. So on the left-hand side, we have some work we did with a 3mm thick PMMA. This is actually the Elium material, a glass fiber Elium composite. And we put 1mm of coating on the surface of that panel. And you can see with the orange line, you have the exposed temperature. So we were exposing the panel for 30 minutes, first of all at 600 centigrade, and then for 20 minutes at 1000 centigrade. And the blue line on the curve to the left is indicating the temperature of the unexposed surface. So the inner surface on the inside of that 3mm thick substrate. And as you can see, it's crept a little bit above 200 centigrade, but we blocked out almost, well, over 700 centigrade from getting to that inside surface with the use of our coating. If you didn't have the coating, then you'd see that unexposed temperature curve rapidly increasing up to meeting the exposed surface temperature, of course. So what's important is we're achieving a protection, as you saw earlier in the video, and that protection is stabilized. Once you get to about 10-15 minutes, you're getting a horizontal curve. You're not getting much of a temperature increase on the unexposed side. On the right-hand curve, a slightly different project here. We're looking at pressure vessels, somewhere in the region 25-30mm thick epoxy carbon fiber, a little thicker coating. But again, a very important result for us, achieving 200 centigrade performance as a maximum temperature, 1mm down from the surface of where the fire was hitting the substrate. So just 1mm below the surface of that vessel, the temperature was maintained at 200 centigrade for over 40 minutes. It's a really quite an impressive result, we believe, because that shows at 200 centigrade, you're not really radically changing the structure of the epoxy carbon fiber, you're maintaining the structural performance of the vessel, and very importantly, showing the stability and the protection of our technology. Few more curves to show you. This is related to heat release. The heat release standard for running heat release testing is something called ISO 5660, using cone calorimetry equipment that we have here in Finesta. And we run these tests in-house. This is just showing what happens when you take an uncoated polyester glass fiber for cladding wall panels, and you put our two-coat system on, that's the blue curve. You reduce this MAHE value. This is the maximum average rate of heat emission. So it's a way of measuring heat release or heat emission. And we reduce it by over 50%. We take it down to 100 from over 200 with our standard two-coat system. And the shape of the curve is also interesting. So you see that little peak, first of all, of the blue curve is where that organic material is being burnt off in the initial stages. And then we're getting this ceramification and controlled and delayed and lower heat release resulting. I promised you earlier a little bit about the consistency, and I think this is a very interesting curve that we've created here. We made 3 repeat samples 3 separate times with our two-coat system, applied over uncoated polyamide glass fiber. Yes, we can get a reduced number as we would expect with this MAHE number, but more importantly, we get reproducibility to within 1 or 2 units of MAHE. Now, you don't see that with standard composites. This is a very impressive result and showing the consistency that you can achieve with coatings, fixing any irregularities within the composites, and certainly giving you a high level of confidence when you're claiming fire classification. A couple more on the testing protocols. Flame spread. So flame spread is run by a couple of standards. ISO 5658 is the international standard used to determine flame spread. Again, some numbers. The numbers in the table are from certified third-party laboratories, confirming that we are consistently above this critical number of 20 for the critical flux of extinguishment, the CFE number. That means a pass under the railway standard. On the right-hand side there, you can see a picture we took a few days ago from our labs. Again, we've got this indicative test in our laboratory, able to simulate a flame spread. So simulate this 5658 testing, and it gives us indicative results to the CFE as well. And as I mentioned before, the BS476, we get the best in class, the #1 result for the BS476 Part 7 in terms of flame spread. So what this means is our coatings, once they've been exposed to fire, they may burn for a little bit, but the flame won't spread along that panel. The flame will be contained to one end of the panel. You won't get the flame spreading along the surface of the cladding or panel or component, which obviously means it's a safe situation. And usually you will see self-extinguishment. You'll see that the flame will actually die down and extinguish itself and put the fire out, basically. So very important to keep an eye on flame spread when you're running these tests. And then I think, yes, the final slide in terms of the performance data, a little bit on smoke and toxicity, always a concern when you're running fire. What's happening to what you're emitting, what is the toxic fumes and the smoke coming out. And again, some third-party laboratories have done some test work, and these are just some example results from those laboratories. And we're getting very consistent, very good to excellent results. So there is some smoke and there is some toxicity, but these are very low numbers, well below the thresholds that are required to meet the classifications for transport and the construction industry. So we have no concerns whatsoever recommending red for use on the inside of buildings or in transport vehicles. Okay, I'll hand back to Harry now to take you through how we would assess whether our technology is right for your purposes.
Thanks, Trevor. That was great stuff. A bit heavy, but great stuff. So, is the red right product for you? Well, the short answer is that we don't know. But the longer answer is that let's find it out. So let's do a viability assessment. What does it mean? So it means that we would have a two-way mutual communication. Of course, we can have NDAs first if needed, but the communication, two-way goal setting and two-way commitment. And we can divide it in parts, the technical specification part, where we define what kind of fire test, what kind of fire level is needed, what fire test needs to be passed. If there is, for example, UV requirements, maybe color requirements, and what kind of substrate we are using. Is it epoxy? Is it whatever today you're using? We need to define it. The other part is the process integration. So what is your process currently, or are you planning a process that will be integrated? What is the application method? Is it spray? Is it a roller? Is it continuous laminating? And what are for example, the curing times? These are quite nicely can be defined and communicated. And the third part is the business opportunity. So what is the timeline for the business to start? Is this the new business? Is this an upgrade for the current business? What are the volumes? And these need to be communicated. But of course, there are plenty of other things, other parameters. These were just the examples, and not all of them are here included. But we need to find this out so we can have, of course, a success. So if this is in the balance, the more we know, the more we can help you, and we both will have a success. Oh, that was a drawing, but what does it mean in practice? So in practice, it means that let's discuss in the Teams meeting, let's discuss face-to-face when we can do that, about your technical requirements. Let's discuss about the desired process you would like to have, and let's discuss about the business opportunity. And if we both think that there's a match, this is worth pursuing. So the next step would be that you would send us a sample of your material. And we will do the compatibility test here. We will code it, and we will make a reference burn, and we will analyze the results, and then we will recommend the next steps. So we go step by step, and when we will see that everybody is happy, and we will have the nice roadmap to success. So in conclusion, there's no need to change your composite. You just put red on top. And we will match our products to your application, your process. And we will give you full fire test guidance and support, and modifications, optimizations. And new applications are, of course, very welcome, which is not today even done. So some thermoplastics, natural fibers, bio-based materials that are uprising markets. So red fire protection coatings will complete your composite. Next steps for the webinars is that we have 2 more webinars coming this year. 23rd of September, we have marine and aerospace. Very interesting stuff there. And we have 2nd of December, we have new energy. This is also very exciting. And then, reminder of that Q&A. I guess there are already some questions. I don't know if there will be answers, but at least we have questions. And we will dig into those while you can watch this nice video about thermal insulation. So, Trevor, do we have questions?
Yes, we have quite a few questions here, Ali. Let me, which I've published. If we just go up to the top here. We have the question about is the coating translucent?
Yeah. Hybrid red, the top coat is translucent. The pure red, the underneath coating, is not yet. It's not yet translucent. There is a development going on, but not to make too many promises. But no, not yet.
Okay. We have the question from Martin about filling pinholes can be difficult with spray application tending to catch air. Does this affect the FR properties?
If it's very pinhole substrate, then the recommendation is to fill the pinholes with the cloth putty or just standard methods, because putties are usually highly filled. Adding putty to the pinholes is not going to change too much the fire performance. But if you have a pinhole surface and you have air pockets, there might be an issue with the fire performance.
Okay. We also have a question about applying our coatings onto a fresh polyester with its high styrene content. Any comments on what would happen there?
Green polyester, our Pure technology is polyester based, so that's fully compatible. You can use it as a gel coat, you can use it as a coating, and you can use it on a green polyester. But anyway, post-curing is always recommended before any kind of fire testing, and that's because of entrapment of styrene and entrapment of unreactive materials. So post-curing is always recommended, but they are compatible with process-wise in a green polyester.
Then we have a question from Bharat asking about how easy will this coating be applied in a continuous lamination sheeting process?
The continuous laminated sheeting process is okay. Let's say the Pure Red as a gel coat is completely fine. We can tweak it to cure it in a few minutes, but you have to paint it afterwards with hybrid red. So hybrid red is not a gel coat at the moment. So Pure Red, continuous laminating process, fully compatible, demolding and painting.
Okay. Couple of questions about the technology. So question about what is the binder base of the coating and what is the thickness of the coating?
Well, the Pure Red, already mentioned, that's unsaturated polyester, very common and easy to use technology. Hybrid red is something that we do not disclose, and that's the name implies it's a hybrid technology, inorganic organic technology, but the further details is not public information. And the thicknesses, so it varies on the fire standard you are trying to reach. Standard normal, what we have done is 400 plus 400 grams per square meter, so totally 800 grams per square meter, which is something like 600 microns total thickness. But it can also, in the hydrogen cylinders, it can be also 2 millimeters. So depending on what kind of fire protection is needed.
One further question is pointing out that EN 13501 is for a system and not for a coating. So how to make sure that you're meeting EN 13501?
Well, you need to make the SPI test, coated final PC, not for the coating. Composite needs to be tested as a final form, not just the individual components. So if you have a coating that gives you, let's say, 50 mare and then heat release, and then you have a substrate that gives you 50 heat release, so they don't add up 100. It's something else. So it always needs to be tested as a final appearance in the final form.
Okay, so further questions about whether the thin ester red could be included into the unsaturated polyester resin itself to improve the fire performance.
At some level, yes. At some level, yes, but the resin is not it's not the best place to put it, but in technology, yes, it can put some, but maybe we need to discuss separately about this topic. It's not a black and white answer.
Further question would be, would the coating be applicable on steel sections as well?
Of course, steel is completely okay. Yeah. It's much easier. They handle better, much higher temperatures than composites, and that is the one reason why incandescent paints made for steels will not work with composites, because steel can handle 500 degrees and composites on 200, so they are not isolating enough. So, but these are made for composites, so they are much better than incandescent paints and systems for steel.
A few further questions, Ari. So What are the coatings like in terms of VOC, stroke hazard, etc.?
These are high solid coatings, so they have very high solid content and very low solvent content. These are not solvent-free at the moment. That's also in our R&D map to make it more and more solid, less VOCs. The solvent content is about 5%, so it's very low in that sense. But the unsaturated polyester has a styrene inside. We have a styrene-free version also, but that's more or less a price question also if that applicable in that application. But they are very high solid content.
Question from Luca about the cure cycle. Coating itself, what is the cure cycle? What is the drying curing after application?
Well, polyesters can be tweaked. They can be tweaked for 1 minute to 2 hours, and with heat boost, it's instant. Or that's more or less trivial. Hybrid red is more or less there's some limitations for hybrid red, for example, for online pull-through, and it's not very fast. So it's a double curing system, meaning that there's a first reaction with water, and that will make the surface tack-free in a half an hour, let's say, and then the final curing will happen in that cross-linking curing will happen in weeks or days, let's say 10 to 14 days, and then you have a fully cured system. You can heat boost that in 100 degrees, 150 degrees for a couple of hours, and that's done. But normally you cannot heat boost that. You need that first reaction with moisture to happen. It's a bit slow, but it also cures at room temperature, so you just apply and go.
A couple of questions from Matt here. So what temperature does the system start to work, and will the coatings work at high temperatures without a flame?
The coatings the activation temperature is about 270, 280. It's difficult to exactly pinpoint that, but they are high temperature functional coatings also. So if you stay below 200, so let's say 190, 180, 190 long term, they can still perform as normal coatings. So they are high temperature resistant coatings. But in any organic coatings, you should stay below 200 degrees.
And a couple of questions from Catello here. So which grade of toxicity does the smoke produced by the combustion of these coatings present?
I give this to you. You have better this.
Yes, I think in terms of toxicity, it's very much what is the specific test parameters and what is required. So as you know, it's not so much a requirement within the EN 13501 construction standard, but if you're looking at the railway standards or other transport standards, then aerospace, for example, then very much more concern over the level of toxicity. So it's very much, we haven't found that our coatings have failed for toxicity. The slide I showed on the smoke and toxicity ISO 5659 has very low levels of CITG. So that parameter CITG is indicative of toxicity. Yeah, we wait to see where there'll be a problem with that. But no, we haven't had a problem with that.
The coating itself will not produce the toxics. It's the substrate that it protects.
And I think then I had another question here. I'm just finding it. Which kind of tests can be conducted in your labs?
Regarding to what? Sorry.
I guess it's the summary of the test, the fire test that we've mentioned earlier.
Yeah. So we have the cone calorimeter for heat release, and then we have the thermal insulation test. So how much heat is transferred to the material itself. We have a UL94. We have ignitability test. And we have incombustibility test, and then we have what else do we have? What did I forget?
Ignitability, combustibility, thermal insulation, and the indicative flame spread.
And indicative flame spread.
Yeah. Question from Bert about is the red coating halogen free?
Completely halogen free, and there's no fire retardants inside, so it doesn't contain any fire retardants. So it's the polymeric backbone makes it fire retardant or fire protective. So the ceramification happens without any halogens or phosphates or bromine.
Yeah, also a question about whether contain hazardous components like borates.
No.
Shelf life of the products?
Well, normally industry standard 1 year when stored in the right conditions.
REACH compliant?
Of course.
And color of smoke was also one question we had in.
What smoke? No. The pure technology have some. Styrene will generate some black smoke if that's really visually checked. Hybrid will not generate a smoke at all.
Okay, I think we have time for one final question here, and I have a question. Okay, so we've got two questions. How long is your product certified for? How long will it last? And then the second part of this is, what advice can you give to designers wanting to convince our clients of the design life of the product and how this can be proven to work? So this is relating to very clearly use of composites in the construction industry. We give assurances with regard to our coatings related to the tests that we can do, and with all coatings companies, it's accelerated weathering testing. We run the simulation testing in the laboratories, and if you can run for 5,000 hours, that's often seen as a 20-25 year durability. The coatings have been commercially used now out in the open air for 3-4 years, and we had no issues so far. But in terms of the test protocols and what we're doing, we use the accelerated weathering. Obviously, we use exposure testing, and we certainly have no concerns over it lasting the 25 years. Obviously, requiring regular maintenance or inspection, so ensuring that there's been no damage to the coating in the period of time. And of course, that maintenance, as I mentioned earlier, can be repaired with repair coat versions of the coating. Advice to designers to convince clients. I think we want to work on a case-by-case basis. We're working with a number of construction or another number of composite manufacturing organizations who are trying to build the case for greater use of composites in the construction industry. We're making great efforts ourselves, but also across different parts of the construction, the composites industry. We're aware of efforts in supporting those. I actually chair the Fast Smoke and TOX working group for Composites UK, and one of our main targets and activities is to educate and show and demonstrate how composites can be used as alternatives to steel and to concrete, of course, in the construction world. So yes, we're putting together dossiers. Please come to us. Let's see if we've got something that can help you convince designers and architects. If not, let's try and put something together.
We have 2 minutes. One more question. Of course, we will answer your questions and send us emails. Of course, that's no-brainer, but maybe we have one more.
One more question. Yes, we have a question from Luca. The coating should be applied on both parts of the laminate or also on heating flame side?
No, only one part. Only one side, that exposed side, the laminate. Of course, the edges are important. So you have the facing side and then edges, protect the edges, because then the edges might have a weak point if they are not protected.
And one more final question from Ralph. How can you avoid toxic vapors while application to workers? So I guess it's
for personal protection,
referring to the small amount of solvent content that we have in the coatings.
But even if it's a solvent-free, you should have a personal protection because you have a mist. You should not breathe the mist, even it would be any kind of mist. So personal protection. These are not edible chemicals, but they are not the worst. Similar to polyurethanes in the sense of protection, even these materials don't contain any isocyanate, but similar way of protection and application. Okay, I guess that's it. We have used our time quite nicely. Thank you very much. Oh, the video ran out also quite nicely. You can still see the ending, and there's really nothing much to see. a bit boring video, but we managed to watch it thoroughly. Thank you for everybody, and have a nice rest of the week. Bye bye.
Thank you. Goodbye.